Water just ate through solid steel. This is a real pump wheel, pulled from a working plant after a few months of use. Not rust, not corrosion. Something invisible did this. Stick around, because by the end you'll know exactly what force destroyed it. And why that same invisible fight is happening in your building right now, every time someone upstairs turns on a tap. Underneath every city on Earth, machines called pumps are moving billions of liters of water uphill and sideways, non-stop, without a single person noticing. Until one of them loses. Here's the twist though, most water needs zero machines. Gravity moves it for free. Old towns were built on hills specifically so water would just flow downhill on its own. So what happens when your city is flat? Take Berlin. Dead level. Gravity has nothing to grab onto, so the utility has no choice. Motors have to physically shove water sideways for miles and lift it floor by floor. When gravity clocks out, a machine clocks in. And there are only two ways to build that machine. Option 1 traps water in a chamber and shoves it forward with a piston. Precise, slow, and basically extinct outside of museums. Option 2 is the one running practically the entire planet's water supply. Picture standing on a spinning merry-go-round holding a bucket. Spin fast enough and the water flies outward. That's centrifugal force. Now trap a spinning wheel inside a sealed casing, and you've just built a pump. That wheel is called an impeller. Water hits dead center, gets grabbed by curved blades, and gets flung outward at speed, then funneled through a snail shell chamber that converts all that speed into raw pressure. Spin in, push out. Tall and narrow for squeezing water up a deep well. Fat and flat like a propeller for moving a flood's worth of water fast. Same wheel, different shape, different job. But every pump has one unbreakable trade-off: push harder for more flow and pressure drops. Push for more pressure and flow drops. You can't sprint flat out while also hauling something heavy uphill. Pumps face the identical compromise. So what do you do when one pump isn't enough? You don't build a bigger one. You add more, side by side, in parallel, and their flows simply stack. More checkout lanes, more customers through the door. Or you stack them nose to tail, in series, and their pressures add instead. A bucket brigade, each hand adding a little more push. That's literally how a borehole pump works, a stack of tiny wheels on one shaft, pushing water up from hundreds of meters underground, stage by stage. Now, remember that ruined wheel from the start? Here's exactly what happened to it. As water rushes into a spinning impeller, pressure at that entry point crashes, and if it crashes far enough, the water starts to boil, not from heat. From the sheer absence of pressure holding it together as a liquid. Tiny vapor bubbles form inside the pump. Then, a split second later, they slam into a high-pressure zone and collapse, violently. Each collapse fires a microscopic jet straight into the metal. Do that a few million times, and you get exactly what we saw 60 seconds ago. Engineers guard against it with a mandatory number called NPSH, a required pressure cushion at every pump's inlet. Every pump on the planet gets checked against it before it's ever switched on. Skip that check, and this is what you get back. Now, the second mystery. Climb a skyscraper, and city water pressure quietly drains away floor by floor. By floor 10 or 15, plain street pressure often can't reach the tap at all. The fix lives in the basement, a booster station, a dedicated pump whose entire job is repressurizing water just for the upper floors. Your shower on floor 20 has its own private pump crew, 200 feet below you. But if that pump clicked fully on and off every single time someone opened a tap, it would burn out in months. So there's a sealed tank half full of water, half full of compressed air, a cushion that absorbs the swings so the pump clicks on a handful of times an hour instead of hundreds. That's the tightrope every water pump on Earth walks right now. Never so little pressure the top floor runs dry, never so little pressure at the inlet that cavitation eats the impeller alive, never cycling so hard the motor cooks itself, all day, every day, for decades. So next time water just appears the second you turn a tap, remember there's an unglamorous spinning wheel somewhere below you, walking that exact line right now. Lose that balance for even a moment, and you already know exactly what gets left behind.